Now for this part, we've got to show that e of x squared equals 9.8 for this probability density function. And to do this, you've got to be familiar with the formula that e of x squared equals the integral from the lower limit to the upper limit of your distribution here. We tend to write this as going from minus infinity to infinity. And then it's x squared multiplied by f of x dx. So if we apply that to this question here, then e of x squared is going to equal the integral going from 1 to 5 of x squared multiplied by f of x. Now I've left a little bit of a space here because this being a constant, it's best to bring this out the front. You don't have to, but it does make the integral a lot easier to handle. So then you've got x squared times just those two brackets, x minus 1 multiplied by 5 minus x, and that's all integrated with respect to x. Next I would want to expand some brackets, so we'll just copy that 3 over 32 in, and the integral going from 1 to 5. So I'll leave the x squared there and we'll start to expand these brackets. So we get x times the 5, which is 5x, and then I also notice we're going to get plus 1x, so that's going to give me a total of 6x there. As for the x squared term, x times minus x gives me minus x squared. And then finally for the constant, you've got minus 1 times 5, which is minus 5. And that's integrated then with respect to x. Next I'd want to expand that bracket totally out now. So it's 3 over 32, the integral from 1 to 5 of 6x cubed, and then minus x to the power 4, and then minus 5x squared. There's several terms here, so do make sure we still keep it in brackets, and that's integrated with respect to x. Now in the usual way, to integrate something like this, what we have to do is add 1 to the power on each term and divide by that new power. So for the first term here, you've got 6x cubed, but you're going to have to add 1 to that power, so it's going to be 6x to the power 4, and then divide by the new power, so that's 4, minus x to the power 5 over 5 minus 5x cubed over 3. Okay, and that's going between 1 and 5. Now we need to substitute our values in, 5 first for x, and then subtract what we get when we put the 1 through. So because I'm starting a new line here, I'm going to copy that e of x squared back in again. So therefore e of x squared equals, well, we've got 3 over 32. Now I haven't really got too much room here, but essentially, as I say, you put the 5 through here. We can actually cancel some of this out actually. Look, 2's into the 4 goes 2, 2's into 6 goes 3. So when it comes to substituting these values in the usual way, we're going to have 3 over 2 then, multiplied by 5 to the power 4, 5 to the power 4, and then minus 5 to the power 5 divided by 5, 5 to the power 5 over 5, and then minus 5 times 5 cubed over 3, 5 cubed over 3. And then, well, put this in brackets there. Okay, and then we've got to subtract. So as I say, I'm going to have to go on to the next line here, which I don't really like doing, but there you go. I'm going to have to do it this time. All multiplied by, put the 1 through, and you've got 3 over 2, and then minus a fifth there, and then minus 5/3. Okay, so we got all of that. So get on your calculator, work that out, and bingo, what you get is 9.8. Alright, what we had to show. So do check that out, you will get 9.8. Okay.